Okay, this is Regents Chemistry, and this is a review of intermolecular forces in the bonding unit. And this is the very last video that I am doing for this unit. Next unit, we will be doing physical behavior of matter. So I'm going to begin by just reviewing the three types of intermolecular forces that we focused on in this unit. The first type of intermolecular force, and remember when we're talking about intermolecular forces, we're talking about those forces between molecules, not the forces or the bonds within the molecule, but those between the molecules. So the first one is called London dispersion forces. We refer to them as LDFs. They are the weakest of all intermolecular forces, and they're important for nonpolar molecules. Remember, we can be nonpolar by if we're Brinkelhoff, or nonpolar if we are symmetrical. If you have two nonpolar molecules, the one with the greater number of electrons is going to have stronger London dispersion forces. And London dispersion forces basically are the electron-electron repulsions that create these brief dipoles. The electrons are constantly moving, and due to the repulsions, one side of the molecule becomes slightly positive and the other slightly negative in a temporary dipole. The next type of force is dipole-dipole, and dipole means two poles, and that's because we have two different elements, one with a higher electronegativity than the other. The one with the higher electronegativity gets the partial negative charge. The one with the lower electronegativity gets the partial positive charge. So as a result, we have unequal sharing of electrons. Because of this partial negative and partial positive charge, when two dipole molecules come in near contact with one another, they have a temporary attraction due to these partial charges. Remember, the higher the dipole moment, that means difference in electronegativity, the stronger the intermolecular forces. The stronger the intermolecular forces, the higher the melting and boiling point. This is extremely important for you to remember. If I have a low melting point, it's because I have a weak intermolecular force. If I have a high melting point, it's because I've got a strong intermolecular force. It is a direct relationship. And the third type of intermolecular force we discussed were hydrogen bonds. And this is a specific type of dipole attraction. This type of dipole attraction only occurs when hydrogen bonds with fluorine, oxygen, and nitrogen. So if you've got hydrogen and one of these other elements that forms a compound, when they become near each other, there is this strong polar bond. And that's because the electronegativity of the other element is so high that it pulls the electron that hydrogen is sharing with it basically almost from it. So it says it's reduced to a bare proton with almost no atomic radius. And that is the strongest by far. Please remember, we talked about the phrase to help you remember, never imagine me having dirty napkins, and that stands for network solid, ionic, metallic, hydrogen, dipole, and nonpolar, which is our LDFs. So let's review some questions dealing with intermolecular forces. Which of the following will have a higher boiling point, and explain your answer? Well, right away I see that this is nonpolar, so I know that it's going to have LDFs, which is the weakest of the forces, and this, NH3, it is dipole, but it's the special dipole, and it has hydrogen bonds. So hydrogen bonds are the strongest, so the NH3 is going to have the higher boiling point. Why does dry ice, solid CO2, evaporate before sodium chloride? Well, remember that for things to stay in the solid state, you need to have some attraction of the atoms to one another. The weaker the attractions, then the particles increase in entropy or randomness. So solids have the most entropy, while gases have the least entropy because they're all spread out, they're all over the place. So if we look at sodium chloride, NaCl, you have a metal and a nonmetal, you know that that is ionic, and that's very strong. Where CO2, you know, this is nonpolar by symmetry, so this is going to have LDFs. So if I've got very weak forces, I'm not going to be able to stay in the solid state. So if you know anything about solid CO2, this is dry ice. Dry ice goes from the solid directly to the gas phase, which we're going to learn in another unit is called sublimation. And that's because these LDFs are very weak forces. So it can't hold the CO2 in the solid state. Unlike sodium chloride, very strong bonds, it'll stay as a solid. So evaporate, it's going to go to the gaseous state, the CO2. Why does gasoline CH18 exist in the liquid form while methane CH4, the gas we use to power our Bunsen burners, exist in the gas form, even though both compounds are nonpolar? Well, what did I say? If they're both nonpolar, look for the one that's got more electrons. CH18 has more electrons, therefore greater LDFs. So this is going to stay in the liquid state, which is more organized than the methane going into the gas state. Identify the intermolecular forces that exist in the following molecules. Well, we know this is hydrogen bonds because it's H with O, N, or F. N2 is part of Brinkelhoff, so we know this is LDFs. HCl, Cl's got a greater charge electronegativity than H, so there's your partial negative, so this is going to be dipole-dipole. And then LiCl is a metal and a nonmetal, so this is going to be ionic. Of the compounds in question 4, which has the strongest surface tension? Well, that would be the water, because that is in the liquid state, and hydrogen bonds are very strong. List the noble gases that you see here from highest to lowest boiling point. Well, the noble gases are going to have all London dispersion forces. And what do we know if they're all London dispersion? The one with the greatest number of electrons would have the highest boiling point. So we're going from highest to greatest. So if we look, I wrote these down in order from top to bottom of group 18. So UUO would have the most electrons, therefore it's going to have the greatest melting and boiling point. And helium, having the fewest electrons, would have the weakest LDFs, and it would have the lowest melting and boiling point. Explain why I2 is a solid, Br2 is a liquid, but Cl and F2 are gases, even though they are all halogens. Well, they're all Brinkelhoff, so they are all nonpolar, which means that they all have LDFs. And we've been saying that if you have LDFs, the one with the greatest number of electrons is going to have the greatest forces. So I2 has more electrons than Br2. Therefore, it's going to have stronger LDFs, which will allow it to stay in the solid state. while Br2 has fewer electrons, but more electrons than Cl2 and F2. That's allowing it to stay in the liquid state. And then Cl2 and F2 have the least electrons, they have the weaker LDFs, and therefore they're going to be gases. List the following substances from highest to lowest melting point. So first of all, we have to figure out what our forces are here. So we've got ionic, and then we've got nonpolar, which is LDF. CH4 is nonpolar by symmetry, which is also LDF. H2S, the S is in the same group as O, so these both look very similar. They're bent molecules, and that means that they are going to, well, this one's going to be hydrogen bonding, right? There's your special dipole. This one's just going to be dipole. Even though they look the same, they have two types of intermolecular forces. And this one right here, I don't know if I mentioned it anywhere. This is silicon dioxide. This is sand. This is going to be network solid. We haven't really talked about it. I've just mentioned it. We talked about diamond and graphite. Okay, so strongest. Remember, never imagine me having dirty napkins. Network is the strongest, so that's going to be my ISO2, which is going to be greater than my ionic compound, which is KCl, which is greater than, I don't have any metallic. I do have a hydrogen bond, H2O. Then my dipole. And what else do I have? I have two nonpolar molecules, but the CH4 it's got more electrons, so CH4 is going to be greater than, no, let me see if it has more electrons. Cl2 has 17. Actually, Cl2's got more electrons. Sorry about that. I'm going to think for a minute. Okay, there we go. If the statement is true, write true. If it's false, change the underlined word or words to make it true. A group of atoms united by ionic bonds is called a molecule. That is false. This would be covalent bonds. Covalent and molecular are synonyms. A covalent bond is formed by a shared pair of electrons. That is true. A double covalent bond consists of two shared electrons. Well, here's a prime example of a double bond. Each oxygen has got 6, so that's a total of 12, 2, 4, 6, 8, 10, 12. They're talking about this double bond. Remember, each line represents 2 electrons. So that would be times 2, so that's going to be a total of 4 electrons. So this is false, and this should be 4. Dipole-dipole interactions are the only IMFs that exist in nonpolar molecules. That is false. I think this word should be underlined. So this would be false. And this would be London dispersion. Polar molecules always have a higher melting or boiling point than non-molar polar molecules. This would be true because it has stronger forces. In nonpolar covalent bonds, the electrons are shared unequally between the two atoms. This is false. They're nonpolar because there's no pole, and they are equally shared. Hydrogen bonds are basically a specific, very strong version of dipole-dipole interactions. That would be true. Challenge question, carbon tetrachloride. So here's carbon tetrachloride. So we've got 4 Cl's. Let's not forget our valence electrons. Has polar bonds between the atoms. That is correct. If we look at the electronegativity difference between any one of these, the C and the Cl, okay, the ED is going to be greater than 0. Therefore, the bond is polar. However, the overall molecule is nonpolar because you've got Cl pulling in this direction, this direction, this direction, and this direction. North, south, east, and west. So the pull cancels out. Here they want us to show the electronegativity difference and then the type of bond, which is 3.4 minus H, which is 2.2, which is going to give us 1.2. So this is going to be polar. Remember, greater than 1.7 is ionic. So CC, it's going to be 2.6 minus 2.6, which is going to be 0, which is going to be nonpolar. And then we've got K and F. F is 4, and K is 0.8, 0.8, which is going to give us 3.2. So that's definitely going to be ionic. Makes sense, it's a metal and a nonmetal. N is 3, and H is 2.2. So this is going to be 1.8. So this is going to be polar. Na and F, so we've got 4 minus 0.9, which is going to be 3.1. So that's going to be ionic. And then HH is going to be 2.2 minus 2.2. It's going to be 0. It's going to be nonpolar. Okay, almost done. This will do some review of Lewis dot structures and the type of bond by using brackets and charges or dashes if covalent. So NH3, N has 5 valence electrons, and H is going to come in here on each side, and there's the 2. So this is 2, so N is 5, plus 3 H's is 8, so 2, 4, 6, 8. I've got the right number of electrons. This side's going to be slightly negative, and this side slightly positive because it's polar. PCl3 is going to be very similar because P is in the same group as N, and then you're going to have a Cl here, here, and here, but Cl's got 7 valence electrons. Remember, we want to make sure our electrons add up. So we have 3 Cl's times 7. Do that. 3 times 7 is 21. That's for the Cl. And then for the P, we have 1 times 5, which is going to be 5, which gives us 26. So we've got 2, 4, 6, 8. 8 times 3 is 24, and 2 is 26. This is also polar. This side is going to be slightly negative, and this side slightly positive. The east and west on both of these cancel out. H2 is simply like this, nonpolar. CCl4 So you've got 4 times 7 for the Cl. 4 times 7 is 28. And you've got carbon, which is 1 times 4, which is 4, for a total of 32. And you've got 2, 4, 6, 8. 8 times 4 is 32 electrons. MgCl2 is a metal and a non-metal. It's going to be ionic. So you've got Cl, well, you've got Mg that wants to give up 2. So there's one Cl. And I can put the other Cl either on this side or on the bottom. I'm going to do it on the bottom. Remember, nonmetals get the brackets, shows ownership. They each gained 1, so that's minus, minus, and the magnesium gave up 2, so it gets the plus 2. KBr, K wants to give up 1, Br's got 7. So Br gained the electron from K, it gets the brackets, gained 1, and potassium gave up 1. And that's it. I hope that that helps. I hope that you study, and I will see you next class for the test.